Share the screen. Welcome everyone on our Cozystack community meeting. Today is 31 of October. I'm hosting this meet, Andrei Kvapel, and also please put your names into these documents. I will just post it into link to have the opportunity edit it. And you can just join to this mailing group and you'll get the permissions to manage to edit this file accordingly. So today we probably don't have anyone on the meeting, or is there anyone? If there anybody new who would like to introduce yourself, it's a good time to tell a few words about yourself. Okay, in this way, let's switch to the agenda, and I'm going to show you the new API server approach, which we developed for Cozystack. And I'm going to reshare it to my console. So probably the next version of Cozystack will have a new API server, which we wrote. This API server done using aggregation API approach. That means that we don't have any CRDs, or let's see, kubectl API resources. We can see that there are a lot of resources from Cozystack, but there are no CRDs for them. This is done using aggregation API server approach. So we have API services. Here is Cozy System Cozystack API. The new pod is created in Cozy System. And this pod is serving actually our API resources. It can be configured dynamically through the specific configuration file. Here, we can define that. I'll just remove it to enable highlighting. Here we can define that these specific resources with such kind, singular and plural names will be mapped to specific Helm chart releases. It will automatically add Helm repository, and also it will match existing releases and find that exactly these charts should be defined as this kind. And now let me show you how it works. So we have new resources. We can simply run get Kubernetes and see that new resources are created. We can see the definition of this resource. This is a bad example. Okay, I have test 3 and test 5. Yeah, test 5 have more parameters. So we introduce the mapping, transparent mapping of Helm values into custom resources. Now this resource, exactly Kubernetes test 5, mapped from the Helm release in tenant collapse, Kubernetes test 5. So it just takes all the values you have here and put into spec into our newly created resource. If we change something here, it will also populate the changes into the API server, because our API server have no state. it is not specific controller. It just every time when you're querying specific resources, it directly translates the Helm releases into this kind of resources. And the same way as Kubernetes, you can query radiuses. Yeah, sometimes it still have bugs, but I think we will fix it before the release. And let me show how can you create new resource. So we have such example of Kubernetes. So we just defined the normal Helm release, but in the new form. The version of the Helm chart moved to application version, and the values are here. So now we created new Kubernetes. It is not ready yet, but we can wait for a while. Under the hood, it's created new Helm release. Test 2, this one. That's it. This is how it works. If you have any questions or suggestions, please tell me.
Why? Why is it necessary?
That's a good question. The main reason for this that we can't make our back model working with existing Helm releases.
Nice.
So we just want to let users to manage Kubernetes clusters or to create Redis and databases, but not allow them managing other kind of resources. And we really wanted to make it dynamically configurable. Ideally, if it will discover all the existing Helm charts in the repository and also generate resources for them.
Nice.
Yeah, making one of the idea was making controller, but it might be really difficult to sync all the states to dynamically generate CRDs and also dynamically copy the data from one side to another side. Here, you can manage Helm releases, and you can also use new API. So we have win-win in this way.
So you mean that if you write just an operator, then it would be hard to continuously convert CRDs to Helm releases, something like this?
Yeah, because right now the conversion works in both ways. If you create Helm release, it will be shown as this specific kind in this API server. And the same way, if you create it through the API server, it actually creates the Helm release.
And how technically this API server is written? So is it just your code on top of Kubernetes API server, or it is just separate?
There is a project, it's called Sample API Server. I forked it and changed the code. So the main change here, the structure is totally similar to the Sample API Server. The difference is the registry store. By default, it uses etcd. And here I use the new implementation, which directly for every request it use Kubernetes client to query Helm releases. Actually, this kind of releases.
George, please. I answered. Oh, I asked a lot.
Yes, I have two questions. So, first question, it looks like that if we creating Helm release, it should be mirrored in our API server, right?
Exactly.
But it means in the same time, if you will be watching the creation of all objects, of custom objects, it will create an excessive amount of queries to Kubernetes API server, because you never know when Helm release was changed, in fact.
Yes, you don't have to watch.
Please,
Yep.
second thing. So from my point of view, to be honest, I think that the synchronization should be only one way. So if we are creating a resource in custom API server, okay, it's fine if underlying Helm release would be created, but not vice versa.
There is no any actually synchronization process. Just imagine that you have Kubernetes, but with the backend storage, not the etcd, but the other Kubernetes. So in this way, there is no synchronization. Those resources are not existing, they're ephemeral. So anytime.
Yes, but it means in the same time, if they are not existing, every operation on this resource, like get or watch or anything else, it will like call some function inside of API server. But in the same time, it means that it would be inefficient, because if you need to go to some external entity like Helm release for every query, yeah, it means that watches won't work at all.
It will just proxy this request. So even if you use watch, it just runs the watch for the Helm releases.
Yes, but what if you want to create like a new Helm release, and I may guess it would be instantly shown here, right?
Yep. But it will be shown, it will be processed only if you have watcher enabled. If nobody runs watch, it will not be existing here.
So it's really on the consumer of this API.
Yes, but it's just sorry, Kingdom. It's blowing my mind. So you could not watch something if it's not existing in the cluster.
Yeah, because this list is generated on the fly.
Yes,
anytime when you start watching request, it starts. So you go to this proxy API and it proxies it runs its own watch for the Helm releases, and then transparently transcode the answer to you.
So it's filtering?
Yeah, it's filtering. It's filtering according to the fields. For example, if you're querying Kubernetes, it will remove the prefix from the name and also will match if the release have chart Kubernetes and if it's installed from the specified here Helm repository.
I always thought that was a sort of ugly convention, but it sure enables this API server here.
What do you mean?
I think they call it Hungarian notation, where you put the name of the thing in the front of the, or the name of the type of the thing in the front.
Yeah, but we have different types of resources which can be deployed in the same namespace, and they usually Helm charts, and every Helm chart have this prefix. Actually, we're querying only.
Very well, I think. Yeah.
Yeah. Actually, we're querying only Helm charts, so we don't query any resources created under the it. So it directly queries Flux CD resources and removes the prefix from them, and also matches. So filtering it from according to the chart name and a repository name.
To be honest, it looks similar to how versioning of APIs works in Kubernetes, when you have like v1 alpha, v1 beta, and it is transformed on the fly.
So, yeah, this is similar to this. In Kubernetes, you can have storage version, and if you continue using old API, you have conversion, which will convert it to the storage version itself. I think Flux CD implements this, so you can work with Helm releases. Currently, they are version 2, but our dashboard is still using version 2 beta 2.
Is this project open source? Can I have a look into the code?
Yeah, sure. I will refactor it a little, and I think I will publish into our repository this week. So
Thanks.
I think this might be a core for Cozystack, and we are going to make API first, and probably later we will create new dashboard which will work directly with those resources. Any other questions? If no, we can switch to the OpenFlower. There is one topic to discuss. Probably the same topic we discussed lately. So we are going to consider various roles for default roles which can be assigned for the users. The main idea here that we continue using our tenant model, but for every tenant, the specific group, OIDC group or OIDC user can be assigned. And I was just thinking what kind of roles, what kind of default roles we can provide. Any thoughts here? So I
think we discussed it in one of the previous meetings, not?
We discussed the model for this, but we not discussed the roles itself. So we probably need cluster administrator. Cozystack cluster admin, which will be able to manage all the resources except Kubernetes resources. So it will be able to create new Helm releases, remove Helm releases, but not manage Kubernetes releases, Kubernetes resources. Do you agree on that?
But it means that you need a real cluster admin.
Yeah, but I think that we can
and also I highlighted a very important thing. So if this guy has right access to Helm releases, yeah, so he can bypass the security and with installation of any arbitrary Helm release, change any object in the cluster.
That makes sense. So we can switch to just providing access for our new API.
Yes, because the rbac of the Kubernetes is not very rich in features. So it rich, but it could not like select subtypes of resources or do something like this. So if you need to like give an option to like install Postgres cluster, but not giving an option to install Redis, you need to write your custom resources and segregate rights.
Yeah, I just thinking that we also have to have specific system administrator which will set up Cozystack itself, and we need to provide limited access to the Cozystack resources. So I think it can be the same, but it should also allow to write access to storage classes. To the metal-B config and to Helm releases and Cozystack config. Something like that. Exec into Cilium pods. I don't know what should be else.
I think when you make statements that he needs right access to Helm release, it means that effectively you can just give him a cluster admin. That's all.
Actually, yes. I think this role can be upgrade it to cluster admin with a tricky way. But the main reason for having it is not to let user shoot his leg.
Look, it sounds like you are making the rbac very complex. So you like, okay, storage classes is simple. Yeah, okay, good. Metal LB config. What is a metal LB config? It's an arbitrary config map in a specific namespace. Not very good. Helm release, arbitrary Helm release. Not good at all, because again, as I mentioned before, it means that he will be able to like change any object in the cluster.
But his cluster admin is able to do this.
Exactly, into Cilium pods, effectively, the same shit, because if you have a cube, if he will be able to deliver a kube stale utility into Linstore or Cilium pod, he will effectively got a cluster admin. So please, remove all this stuff and don't care, because creating some like security measurements right now, you won't make them effective, first of all, and you will just create some barriers that would be like a problem issue for the cluster operator.
Okay, let's call it full cluster admin. That's actually the same cluster admin role we having, the default role we have in Kubernetes.
Yeah.
But we can just define, I don't know, I'm just thinking that it makes sense to create some low privileged role, just not to limit the access, but not to let users to shoot their legs. I mean, to restrict some operations like remove namespaces.
Andrei, sorry. I want to say that if you giving write access to storage classes, to metal LB config, which is very important thing, yeah, it means that he will be able to change the networking and storage.
Yeah,
so
sure.
Anyway, he will be able to ruin the cluster anyway, if he have an intention.
Yeah, but it's still less possible than having the full cluster admin privileges.
Yes and no.
So this role is under the question. I'll put Cozystack cluster admin back, and then we can also consider tenant admin. So probably read-only access to everything in tenant namespace, and write access to our API resources in tenant namespace. Tenant read-only. Something like that. I know that they can read the secrets. I think we can restrict it just to have read-only access to our API resources.
The same should apply for Cozystack admin. So again, if you are stating that Cozystack admin has a read-only access to everything, it means that he can escalate and get the cluster admin privileges by just taking a token, a secret token from one of the secrets.
Makes sense. But what if we'll restrict them to have access only to the tenant namespaces?
It should be enough, but I think you should come from other side. So let's say what are responsibilities of every of this guy. Yeah. So what I mean, let's say Cozystack admin. Yeah. What is his responsibility? Should he have an access to the logs of operators for debugging some issues?
Probably don't.
if we understand the responsibilities of every person, it means that we can write a proper rbac model, because otherwise it's like we don't understand the use cases.
Okay, I like this idea. I like this approach. Let's try to do this. Cozystack cluster admin. That's a guy who installing the cluster. He probably need to have full access for everything.
Yes, full access.
Responsibilities, configure networking, configure storage, configure Cozystack itself. I think we can limit them to see the operator logs. Should we? Because probably every time when we spawn new cluster, we can just delegate it to the user. And we want to. This is probably administrator. So Cozystack admin should manage tenants.
Please don't care about formatting right now. We can fix it.
Yeah, sure. And probably nothing else.
So manage tenants, you mean create tenants, remove tenants?
Yeah, actually create this structure, like create organization, start, provide them opportunity to use tenant-specific services like monitoring and CV, DFS, etcd.
Should he be able to install anything for the exception of tenants?
That's a good question. I think he don't.
I agree, because probably he should not change the configuration of tenant specific services.
I think they need to have the opportunity to manage and changing the configuration of etcd, CV, DFS, Jinx ingress, and so on. But not the ordinary applications like Postgres. I mean, which you can see in dashboard usually.
Yes, but they are not tenant-specific services. It's something like different. So if we are talking, so I mean that it's a correct terminology. So tenant-specific service is like a service deployed in a specific tenant, like Postgres.
Yeah, we still don't know how to call it. We can call it extra because they currently store in extra directory.
Maybe.
Extra.
So in fact, it's a services that could be common to several tenants.
Those kind of services which are usually get installed when you're installing new tenants, and they can be installed just once in tenant namespace. So I would say this is services.
I think that we can introduce a new term called shared services. So what I mean like shared, they could be shared between several tenants from the, like in tree form, from the root tenant to a leaf tenant. But if you need, you can disable this sharing.
Makes sense. Shared system services.
Yeah.
Cool. While tenant admin should have the responsibilities to install any application, remove any application, and consume any application. This one should have the opportunity to consume applications. We probably can introduce this large scope roles. And if you need to specify what kind of applications you want to give access, you can use custom roles in Kubernetes. So I think we can start with these 4 type of roles and then extend it if it will be needed with additional roles. Additional roles can be to give the user permissions for executing virtual machines and specific services like databases. So I think this is good to start. If you have anything to put here, let's do that right now, or we can finish our meeting. In this way, if we have no other topics to discuss, going once, going twice, and thank you everyone for attending this meeting. See you next week at the same time.
Bye-bye.
Bye-bye.
Bye bye. See you.